Welcome to day 2 of chapter 1. We're going to get started today by thinking about collinear points. We're going to think about how points fall on the coordinate plane and what that means about distances between points. And then we're also going to get to graphing circles by the end of the day. Alright, so let's go ahead and get started. How can we determine whether these 3 points are collinear? So first you need to know what collinear means. Collinear means they fall in a straight line. So all these points look about collinear. However, it's not just good enough to have something look like it's in a straight line because our graphs can be deceiving. So think of a way we could actually test whether or not these points fall in a straight line. Think of it this way. How many points do you need in order to graph a particular line? The answer is 2. So between any 2 points, there is a particular slope. All right, there's a particular rise of a run. So if 3 points are on the same line, that means that the slope between the first and the second would be equal to the slope between the second and the third. All right, if there are 3 points that were not collinear, then the slope between the first and the second would be quite different than the slope between the first and the third or the second and the third. So let's look at slope. So let's call this first point, point A, the second point, point B, the third point, point C. How do we find the slope between point A and B? Well, you want to see what the rise is for the numerator. So the rise can be found by finding the difference between the y-coordinates. So the difference between -1 and -7. So I'm going to do -1 minus -7 on the numerator. And then for the run, for the x part of the slope, we just want to check the same thing before the x-coordinates. We want to find the difference between the x position in the first point and the x position in the second point. It's very important that when we subtract these two, we subtract them in the same order. So if you're doing finding the slope between A and B, you might want to do the y-coordinate of A minus the y-coordinate of B over the x-coordinate of A minus the x-coordinate of B, which is equal to 6/3, which in turn is equal to 2. So that means the slope between point A and point B is 2, or 2 over 1. All right, slope between B and C, same thing's going to happen where we subtract the y-coordinate of B from the y-coordinate of C, -7 minus 5, and we subtract the x-coordinate of B minus the x-coordinate of C, -5 minus 1, which will give us -12 over -6, which is also +2. All right, so if the slope between A and B is the same as the slope between B and C, we actually don't even need to check the slope between A and C to know that they are indeed collinear. So answer is yes, and your support for that is that the slope between B and C is the same as the slope between A and B. In this next question, we're going to talk about distance. So how far is 5, 12? So 5, let's say that's about here, 12, we'll say that's about there. How far is this point from the origin? Or the origin is known as 0, 0. So in other words, we're looking for this distance, the length of this line right here. Pause the video, see if you can come up with a way to do this on your own. Hopefully you gave it a shot, and if you did get it correct, you probably noticed that triangles come into play. So what's most important here is to look at this distance. All right, the distance between this x-axis and up here at point 5, 12. 5, 12. This distance is 12 units. 12 units. All right, and then the distance between the y-axis and the point 5, 0 is 5. So are you seeing the triangle yet? If you look at this, if you have a triangle where you know the distance from left to right, one of the legs, the distance from top to bottom, another one of the legs, and you do know that this is a right angle, just because of what the coordinate grid is, then you should be able to find the third side, the hypotenuse, which happens to be the distance. So pause it if you haven't already done this, and find the hypotenuse using the Pythagorean. So a squared plus b squared equals c squared is the Pythagorean theorem. A is one of the legs, 5. B is the other leg, 12. So 25 plus 144 is going to equal c squared. That means c squared is 169, which makes c either negative 13 or positive 13. However, negative 13 makes no sense for distance, so we cross that out, and c is equal to 13. So that means that the distance between the origin and 5, 12 is 13 because we made a triangle and the hypotenuse of that triangle was 13. Using the Pythagorean theorem, which is also the same as the distance formula, now we want to write the equation for the locus of points on a plane that is 7 units away from the origin. So what does that mean, the locus of points? Well, here's the origin again. It's the 0, 0 point. Let's find one point that's 7 units away from the origin. All right, right there, that's 7. Okay, that's 7, 7, 7. So here's one point that's 7 away from the origin. Here's another point, 4 points I found. What are all those other points going to be that are 7 away from the origin? Well, when you put them all together, it looks a lot like a circle. So that's what this is. A locus of points, a certain amount of units away from a point, is a circle. We're going to write an equation for this circle using the only thing we know about each of these points, which is that they're all 7 units away from the origin. All right, so for example, this point over here, I don't know what this distance is, I don't know what this distance is, but I do know that this distance is 7. It is 7 away from the origin. Same with this point over here. I know that this distance is 7, even if I don't know what this distance and this distance is. So let's call this distance over here x and this one y, just to fill the space because we don't actually know how far this is and how far that is, but we do know what the hypotenuse is. It's 7. So let's write a true statement based on the Pythagorean theorem that we know about this point. We know that x squared, the distance of, or the length of this leg, plus y squared, the length of this leg, has got to equal 7 squared. In other words, x squared plus y squared has got to equal 49. All right, well, the same thing's true over here. Whatever this y is, so this was like y, x1 and y1, whatever this y is, we'll call this y2 and x1. Whatever they are, x squared plus y squared still has to equal 7. That's true of every single point. So this is actually the formula or the equation for a circle. The number on this side, 49, if you take the square root of it, you'll get back to 7, right? And so that means that the square root of this number is the radius. So in a similar way, when we see an equation like this, now we can work forwards with this. This is actually going to be the equation of a circle. I know that because the x gets squared, the y gets squared at some point, and there's a constant on the other side. So this is a typical formula that you're going to see, or a typical format that you'll see for the equation of a circle. So just like 49 was on the right side of our equation in the last one, and 7 happened to be the radius, that pattern is going to stick. So if you see something in a format like this, the number on the right side of the equal sign is the radius squared. So that means the radius for this circle will be the square root of 25, which is 5. Okay. And then what about the left side? The left side looks a little bit different than last time. Last time we just had x squared plus y squared. This time we have x minus a number plus, or squared, plus y plus a number squared, and that equals the radius squared. In the general equation, we're going to call the number that gets subtracted from the x h, and we're going to call the number that gets subtracted from the y k. So the difference between these two formulas is that in the top one, the center of the circle is the origin. In the bottom one, the center of the circle is h comma k. So what h and k do when there's something subtracted from the x and y inside the parentheses before it's squared is it shifts the circle throughout the coordinate plane. So in this case, h is 5 and k is, well, not positive 1 but negative 1, because remember the formula is y minus k, so that means it has to be in the format of y minus k, which in this case would be negative 1. Right, so k is negative 1. That means that hk, which is the center of the circle, I'll put that there too, center, is 5 comma negative 1. Alright, so let's graph that, 5, negative 1. And then how do we graph the rest? We already know that the radius is 5. So if we go 5 this way, 5 that way, 5 up, 5 down, those are enough points to make a pretty good looking circle. Hopefully you will get better at making round circles, and so will I, as the unit goes on. This equation is actually also the equation of a circle. It has an x squared and a y squared and some numbers, but it looks slightly different, right? Before we had some nice neat parentheses with an x and a squared, parentheses with a y and a squared, and then a number on the other side. Well, we still got the number on the other side, but there are some things we need to do to this equation in order to get it into a format that looks like the one that we know how to graph from. That's a mouthful. But basically what I'm saying is that as it is, this equation is the formula of a circle, but it's not super helpful unless we can get it into the format where we can actually see what h and k are, so we can actually see what the center will be. The method we're going to use to do this is something called completing the square. And the first step to doing that is to write out the same equation as before with your terms kind of spread out weird like I have them. So what you want is your x squared and your x term, followed by a space, and then y squared y term, followed by a space, and then your constant on the other side. What you're going to do is come up with a number to write here so that this will turn into a trinomial, one with a x squared term, an x term, and a constant term, that when you factor it is some binomial squared. All right, we want this because in the other format of our circle, it was x minus some number squared. So that's what we need to do again. We need to have this be x plus or minus some number. So in order to do that, we have a trinomial that's going to be factorable into a binomial. So in order to complete this square, we need to figure out what binomial, when you multiply it by itself, comes up with x squared, that's good, plus 6x. Okay, so what are my options here? Basically 6 and 1 or 2 and, or 3 and 3. Let's do 3 and 3 for the moment. You're going to find out this works best. Oh wait, that's why it can't be 6 and 1. It cannot be 6 and 1 because it needs to be something quantity squared, so these two need to be the same. So in this case, you divide 6 by 2, you know that that's 3, because the inner product and the outer product need to add back up to 6x when we factor in reverse, aka multiply things out. So 3x and 3x, when you add them together, will be 6x. All right, so now all that's left to do is figure out what needs to go in here based on the last term. So when you multiply 3 times 3, you get 9. That means that the number that will complete our trinomial, or complete the square, is 9. Okay, so I know that's probably a little overwhelming the first time you see it, but I promise it'll get a lot easier with time. Right now, all you need to know is that you want to put some constant there such that it will create x plus something squared when it's factored. And the best way to do that is to take this coefficient, the 6, cut it in half, makes it 3, and then square it. So 3 squared is 9. So 9 is what you write down there. Using the same type of process, we're going to do that with the y's. Let me change colors. Okay, with the y's, we've got y squared minus 8y. So if we want to find something that when you multiply it by itself becomes y squared minus 8y plus or minus something, you're going to want to divide this negative 8 into 2. So you want to go negative 4 and negative 4 here. That way the inner and outer products will add up to negative 8y. And then what does that last number have to be? Plus 16. So here's what we did. We completed the square by finding what number makes this a perfect square trinomial. So now we've got two perfect square trinomials on one side and a constant on the other. So the whole point to this was to rewrite this in a format that looks like our old format. So on the left side, now we've got x squared plus 6x plus 9, which could be factored into x plus 3 quantity squared. All right? Y squared minus 8y plus 16 can be factored into y minus 4 quantity squared. So you just created two perfect trinomials that would factor into two perfect binomials squared. I'll stop saying perfect, they're just binomials squared. But here's the thing. You added 9 to this side of the equation, and you added 16 to this side of the equation. Can you just do that? The answer is no, you cannot just do that. You need to do the same thing to the other side. Add 16 and add 9, then we're okay. So this adds up to 49, and now you can see what the center will be what the radius will be, and for your assignment after this video is done, you can graph the circle. Good luck.